Well, we just finished looking at similar polygons, and now we're going to direct our attention to similar triangles. Triangle, of course, is a polygon. And we know that polygons, or in this case triangles, are similar in that they may have the same shape, but not the same size. And so we're looking to prove similarity. And in the case of triangles, the first type of similarity we're going to consider is by using the angle-angle similarity postulate. And the angle-angle similarity postulate states that if two angles of one triangle are congruent to two angles of another triangle, well, then the triangles are similar. And this makes perfect sense since all the interior angles of a triangle are going to equal 180 degrees. And so if two angles are congruent, corresponding angles are congruent, well, then the third has to be congruent as well. I mean, you know, if you take 90 degrees less 45 degrees, and then you're left with 45 degrees. And so there it would be. So we're going to look at a couple of triangles here, our examples of triangles, and this corresponds to example 1, page 478 in our textbooks, and determine, are these triangles similar? So in this first case, over here on the left, well, I see I've got a 90-degree angle right here, and I've got a 90-degree angle right here. But in this triangle on the left, well, this is 44 degrees, and this is 47 degrees. They're close, but no, they are not similar, because no two pairs of angles are congruent. Okay, well, let's look at the one on the right. Okay, so we got like a triangle inside of a triangle here. But we got a couple of clues. These two lines are parallel. We're told that, designated by that. And since these are parallel lines, this means that this line, segment LJ, is actually a transversal, I'm going to extend it on out, of these two parallel lines. Now, if that's true, and it is because we're told they're parallel lines by those little markings, then angle LJK, which is right here, is going to be congruent to angle LPQ, which is right here. And why would that be? Well, if we think back, well, then those are alternate interior angles. So we know then that angle LJK is congruent to angle LPQ. All right, well, there's one set of angles. Well, we've got a common angle here between these two triangles, and that is angle L. Well, obviously, angle L is congruent to angle L reflexive property. It's congruent or equal to itself. And so therefore we can say that triangle KLJ is similar, and there's our similarity symbol, to triangle QLP by the angle postulate. And similarly, if you think about it, if I look over here, well, this angle right here, which I guess would be JKL, and this angle here, which would be PQL, those also would be congruent. Also, by that same theorem, we could look at this as a transversal, this line LK, and they also would be alternate interior angles. Okay, well, there we go. Sometimes it's a little bit hard to see. Sometimes it may help if you extend your lines out a little bit. Maybe you can see it more clearly, reflecting back on properties of parallel lines that we've looked at. But needless to say, we can determine whether triangles are similar or not using the angle-angle similarity postulate.